All right, so we are starting chapter 9 today. Chapter 9 is all about systems of equations. We're going to learn 3 different ways to solve systems of equations. Today we're going to focus on solving them by graphing. So it'll feel a lot like last chapter. We graphed all chapter long. The only difference is now we'll be graphing 2 lines on the same graph. And we'll try to find where they intersect each other. Okay? So a lot of chapter 8 is going to come into play today. And then the other days this week, we'll talk about 2 other methods for solving them as well. That's more algebra, like solving equations, and less graphing equations. So it's a good time. You guys ready? Have any questions before we go? All right. Here's example 1. Example 1, or the first couple examples, are a lot of review from last chapter. So just to kind of get your brains thinking about what we did previously. So if I want to find the slope and the y-intercept, what would I do? Yeah, subtract 2x from both sides. So y equals negative 2x plus 3. Now it's in slope-intercept form. What is the slope? Negative 2. What is the y-intercept? 3. So we write it as an ordered pair, 0, 3. What are your questions? All right, here's number 2. What do I do? Very good. We're going to start by subtracting 4x from both sides. The whole goal is to get y by itself, so we can get y equals mx plus b. And then m is our slope, b is our y-intercept. So what would I do next to get the y by itself? Divide everything by 2. So y equals negative 2x minus 4. What's the slope? Negative 2. What's the y-intercept? 0, negative 4. Perfect. Questions? Again, this should all be a review of what you took a test on Friday. All right, here's number 3. So it's an x equals line. So that makes it a little different. A lot different. What's the slope of an x equals line? Undefined. It is undefined. Good. And what's the y-intercept? There is none. This crosses the x-axis at negative 2. It does not cross the y-axis. What are your questions? All right. What do I do? What?
Divide by 3.
Very good. Divide everything by 3. So what's my slope? Do you know it? Very good. And what's the y-intercept?
0.
Very good. What are your questions? If this feels new, I am not thinking you did too well on that test. So hopefully none of this is like, what? Okay? Any questions? All right, so when we say system of equations, it's one or more equations. So here is a system, y equals negative 3x plus 7, and y equals 2x plus 3. Now, the solution for this system is an ordered pair that works in both equations. So we're going to plug in 2 for x and 1 for y in both of these equations. And if it works in both, it is a solution. And if it doesn't work in both, then it's not a solution. So our first equation, when we plug in 2 and 1, we'd have 1 equals negative 3 times 2 plus 7. Just do order of operations on both sides. 1 equals 1. So it works in that equation, right? Now we have to try it in the other equation. So 1 equals 2 times 2 minus 3. So 1 equals 4 minus 3. That is also true. So is this a solution for the system? It is. Yes, yes it is. What are your questions? All right, here's B. Once again, we have the question, is the ordered pair a solution of the system? All right, so I'm going to plug these in. So up top I have negative 1 minus negative 7 equals 6. Is that true? Yes, it is. Plug it into the second equation. So we have 3 times negative 1 minus negative 7. So negative 3 plus 7 equals 5. What do you think? Does negative 3 plus 7 equal 5? No. It doesn't. It equals 4. So this one is false. So this is not a system. Or sorry, it is a system, but that's not the solution. Questions? Yes. All right, so when we graph these things, these systems, there are 3 possibilities that could happen. And it has a lot to do with the slope, okay? So if the lines intersect, they have to have different slopes. Now, someone just said, well, what about their y-intercept? We don't really care about the y-intercept there. As long as they have different slopes, eventually they're going to intersect each other, okay? And when they intersect each other, that's the solution. The point where they intersect, the point where the lines cross each other, that's the solution for the system. And your answer will be an ordered pair, an x and a y. If the lines are parallel, that's when they have the same m and different b's. You're not going to have any solutions because the definition of parallel lines are lines that never intersect. So this means no solution. There's nowhere where they cross. Or if they have the same m and the same b, they're actually the same line. So if you graph a line and the second line's right on top of the first line, we say that there are infinitely many solutions and all ordered pairs on the lines would work. Okay? Any questions? All right. Example 2 says, how many solutions does the system have? So I want to know the slope, right? Basically, you start off with slope. How can I find the slope of that second line? The slope of the first line is 3, right? We already know that. Yeah, you can start getting everything away from the y. So I'm going to subtract 10 from both sides and then divide by -4. When you divide by -4, the 9 over -4 is just -9/4. And then you have -10 over -4, which becomes a positive, and then 10 over 4 reduces to 5 over 2. Everyone see what happened there? It's a pretty quick step. Let's put the y in the front. Now I know m and b. So what's m?
-9.
And b is 5 over 2. So if I graph these lines, how many solutions would I have? They have different m's. How many ordered pairs would I have as my answer? Look at the chart. We just went over it. When they have different slopes, how many solutions will you have? 1. They will cross each other. The place where they cross is the answer. Okay? Let's look at another one. All right, how many solutions does this system have? So first we want to find the slopes and the y-intercepts. So start by getting y by itself. In the first one, you can just subtract 2x from both sides. And we get the slope is -2 and the y-intercept is 8. We'll need a few additional steps on the second one. Anyone know where to start? Subtract 4x from both sides. And then what? Divide everything by 2. So what's the slope on that one?
82.
Good. What's the y-intercept?
8.
All right. So the slopes are the same. And the y-intercepts are the same. So if I graphed these, what would happen? Yes, ma'am.
No solution or none?
Try that again. Yeah, when you graphed these, you would have the exact same line. So you'd have infinitely many solutions. All the ordered pairs on the lines would be solutions because it's the exact same line. Questions? All right, now we're going to actually go through the whole process of solving these, okay? So here's our system. X minus y equals 3 and x minus 2y equals 4. I want to graph both of these. So I am going to start by getting the y by itself. To get y by itself, I first subtracted x from both sides. When you subtract x from both sides, you end up with negative y equals negative x plus 3. We got to divide everything by -1 to get y by itself, not negative. All right, so we essentially just change all the signs. So here my m is 1, my b is -3. Any questions on that first line? All right, here's the other one. So again, we got to get the x away from the y, so I'm going to subtract x from both sides. And then I'm going to divide everything by -2. All right, so my m is 1/2 and my b is -2. All right, questions so far? Now we got to go through the actual process of graphing these. So the first line had a slope of 1 and a y-intercept of -3. So I'm going to start at -3. I'm going to go up 1, right 1, up 1, right 1, connect it with a line. Whoop, there we go. To graph the second one, I'm going to go down to -2. I'm going to go up 1, right 2, and up 1, right 2. So you can see where those lines intersect. So where do these lines intersect? Right here, right? What ordered pair is that? Anybody know? What ordered pair am I looking at?
4 -1/2.
2 -1. Okay. Any questions? Now, if I want to check to see if this is right, what could I do? Plug it back into the original equations and see if it works. Okay, this will work. Any questions? All right, here's our next example. How should I start this? Subtract 3x from both sides. Good. Then what? Divide everything by -1. Good. So we end up with y equals 3x plus 4. My slope is 3 and my y-intercept is 4. I'm going to wait and graph it in a second. All right, the other one doesn't really look like it, but it is already in y equals mx plus b. My m is 3. What's the b? 0. It's kind of tricky. All right, any questions about what I've got so far? All right, let's graph these bad boys. So I'm going to start at 4 on the y-axis. Then I'm going to go up 3, right 1. I'm going to put a point. I'm going to go up 3, right 1. I'm going to put another point. Oh, I lied. I'm going to go down 3, left 1. I'm going to put another point. Magic. So don't forget, if you're going off the graph, like here I would have just barely been off, you can make the numerator and the denominator both negative, and it's the same thing. -3 over -1. So down 1, down 3, left 1 is the same thing. All right, to graph the second one, I'm going to start at 0. Then what am I going to do? Up 3, right 1. Uh-oh. What's happening? I am looking at parallel lines. They have the same slope. But they have different y-intercepts, so they have different starting points, but they're rising and running at the exact same rate. So what is my answer here? Yeah, you can just put no solution, or you can put a 0 with a slash through it. Don't put a 0, that's something else. But yeah, it's like a circle with a slash through it. What are your questions? All right, here's example 5. All right, how do I get the y by itself on the first one? Good. Subtract 3x, and then what? Divide by -1. This should be a process that does not take super long for you guys. What's my m? 3. What's my b? 5. Good. Over on the right-hand side, x plus 2y equals 3. What do I do? Subtract the x. Good. Divide everything by 2. So my slope is -1/2. Ooh, that's going to be tricky. My b is 3/2. We can handle it. All right. Here's a reminder of what we're working with. So I'm going to start at 5. I'm going to go up 3, right 1. If I do it again, I'm going to end up going off the graph. So instead, I'm going to go back to my original point. I'm going to go down 3, left 1. Connect those. And in this, some of you on your tests were doing like, you were almost making like those dots, the arrows, you know what I mean? Don't do that. Make this as long as you can for systems. Where would 3/2 be? Yeah, that's 1.5. So go right up here. And then when you do your moves for your slope, you'll just go down to the next half. Okay? Everybody see that? So then I go down to the half and then right 2, down to the half again, right 2. Yes. And then you can go ahead and connect those, put arrows on the ends. It does look like, even though the graph was not the greatest to graph, it looks like they crossed right at that point. Right? So I think we're looking at -1, 2. This is one where I would stop and pause and plug it back in. Anytime I deal with fractions, I feel a little less confident when then I'm doing like the rise and the run on exact ordered pairs. So I would just, even in your head, put the -1 in for the x, put the 2 in for the y, and see if it works. It takes less than 30 seconds, and it guarantees you get it right. Questions? All right, here's example 6. First one's already in, y equals mx plus b. So what's my m?
2.
What's my b? All right, awesome. The second one will take an extra minute or 2. What should I do? Subtract 4x from both sides. Then what?
Divide by -2.
Divide by -2. Uh-oh. What's happening?
Same slope.
Yep, they have the same slope and
B.
the same y-intercept.
So
So when I graph these, what's going to happen?
they're gonna be the same.
They're going to be the same line. Okay? If you start at -3 and rise to run 1, and then you start at -3 and you rise to run 1 again, do you see how the two lines are just right on top of each other? Okay? So I have all ordered pairs on the line as my solution. Some students mistakenly say all real numbers. That's not true. It's not any combination that works. It's any combination of two numbers that represent ordered pairs that are on the line. Okay? So all ordered pairs on the line are our solutions. What are your questions? All right, what did we learn today? Do you guys remember what these are called?
Systems of equations.
Yes, systems of equations. Good. And we actually learned solving. I'm just going to put systems. We say systems for short. So solving systems by, how did we do it? Graphing. We will learn 2 other ways to solve systems this week, and then we'll do a little bit of review. Any questions?